have Leetcode map of highest peak. It's the daily challenge, and it says you're giving an integer matrix is water of size m times n that represents a map of land and water cells. So basically, we're given a integer matrix. It's called is water, and if the value of the cell is 0, that means it's a land. If it's 1, that means it's water, right? It says you must assign each cell a height in a way that follows these rules. So basically the answer is going to be something like this right here, where this is the height of every cell. But what are the rules? The rules is the height must be positive, and for every water cell, the height must be 0, right? These are two rules then we must abide with. And then it says any two adjacent cells must have an absolute height difference of at most 1. So basically any two it says a cell is adjacent if it's directly north, east, south, or west. So basically any cell adjacent to the cell must have a height difference of at most 1, right? So this gives us a clue that any cell adjacent to water cells is going to be 1. Why? Because you have to have adjacent cells have to have a difference of at most 1. So that means it's going to be 1 for every side touching water, right? Find assignment of heights such that the maximum height of the matrix is maximized. So we need to maximize the heights of all of these. And then it says return an integer matrix height of m times n, where this is the height, and then if there's any solutions, return any of them. So this is basically the answer, something like this is the answer, right? So starting off with the clue I mentioned earlier about any cell touching water is going to be 1. That gives us a pretty good point to start from. Where, how about if I start from the water cells and expand across the map, adding 1 as I go, basically, because any cell touching water is going to be 1. So let's say if we do a BFS from the water cells and expand outwards, so it's going to start off by having, so for example, let's take the 0 here, right? And let's start off with this, right? Expanding this is going to have 1 to the right, 1 to the top, and 1 to the bottom, right? Expanding this 0 is going to have 1 to the left and 1 to the bottom of it, right? And then if we take these expanded cells and expand from them, right, but have some sort of way to track which one has been visited before, we can actually derive a solution. So basically, in this 0, we have this one, which is derived from this 0 originally. This one, then, if we expand it, it goes down and it goes to the right, but this one was already visited from this one, so we don't increment it. But since this one was brand new and it was never been visited before, we can increment it to 2, right? And then this one, which comes from this one, it goes down, right? And then we can increment it to 2 as well. So the thing is, you have to do this. It's like multi-BFS, where you have multiple cells and you BFS them all at once. That's the way. I actually don't know if this is the best way, but it works and it passes. I started off by having a deck, which is a queue. You can pop from both sides, just the data structure in Python. And then I captured the row and column length here. And then I started adding to our queue all the water cells. I started adding them all, right? And then I have just a map of, just an array of arrays where these are the 4 directions I'm going to go in, and the visited set, right? And then this is the answer. It's just initializing the array with zeros, basically. This is the answer I'm going to return. And then I'm going to go BFS, right? So I'm going to do a for loop for every set of cells in the current queue. I'm going to do a for loop, right? So this is basically going to start off taking all the zeros in one iteration. I'm going to take a cell, and then, by the way, every cell contains its row, column, and its current value, which is 0 because this is water. So it starts off being 0, right? So yeah, this is the current value. If it's in visited, I'm going to skip, because we don't need to revisit a visited cell, because actually that's going to make trouble and probably might increment it when it shouldn't be incremented. And then I'm going to set the value of it in res, which is the current value. I'm going to set it. So basically, starting off, this is water, so I'm going to set this to 0. It's defaulted by 0 anyways. And I'm going to add it to the set, right? I'm not gonna go, and then I'm gonna go loop in the 4 directions, right? I'm just gonna check if it's in bounds because it might not be. So for this one, maybe it goes to the left or whatever, or for this 0. And if it's not in visited, if it's not in visited, I'm going to add it to the queue, basically. Um, you could do the logic of like the checking in the set like multiple ways. This is just one of the ways I did it. If it's not in visited, I add it here and it's going to get added here. But anyways, I add this to the queue and I increment 1 to the value, basically. So meaning this means it's going to go first for iteration. It's going to go in these 2 zeros. I'm going to conquer them, and it's going to add to the queue this one and this one and this one and this one and this one, right? But it's actually not going to add all of these to the queue. It's just going to add the unique ones. So it's going to add this one, and this one, and this one, and this one, and this one. Yeah, it's going to add all of these. And then what happens when I go start off another iteration with these ones is I'm going to visit previously visited ones. So I'm going to skip them. But for example, this 2 is new. So I'm going to visit this cell, find out it's not visited before, and I'm going to increment the value by 1. So that's what happens. And then same goes for here, right? In the same iteration. And then I just keep going, keep expanding until we find the result. And this passes. I don't think there probably might be a better way to solve this, but time complexity wise, it's actually m times n, or yeah, it's m times n here. Potentially, yeah, because I visit every cell and process it once. So it's m times n, and it's also m times n for space complexity. So that's been it, guys. Thank you, and see you next one.